about to. 17.
Can I get a water?
Yep.
Because it's cheaper than.
All right, today we're going to talk about polygons. And if you remember, a polygon is a closed plane figure formed by 3 or more segments that intersect only at their endpoints. Closed plane figure formed by 3 or more segments that intersect only at their endpoints. So in your assignment today, you'll be asked if shapes are polygons or are not polygons. So something like this bow tie is that a polygon or not a polygon?
Yes.
That's not a polygon. Intersect only at their endpoints. All right, these 2 segments that crisscross in the middle, they intersect somewhere other than their endpoints. Okay? Polygon, not a polygon.
No.
Not a polygon. Okay, it's not because it's not a closed figure. It's got a opening. Okay? That's a polygon. Very good. So we'll say that it is a polygon. Now you can have a irregular polygon, which is a polygon where all the sides aren't the same, or you can have a regular polygon. In a regular polygon, all sides and angles are congruent. All the sides are congruent to each other, and all the interior angles are congruent to each other. And then within your regular and irregular polygons, you have concave and convex polygons. So concave. All right, this would be a concave polygon because one of its vertices is inside the shape. Or if you connect non-consecutive vertices, if I connect these 2 non-consecutive vertices, there is another vertex inside of that line. That makes it a concave polygon. If all the vertices stay on the outside of the shape, then it's called a convex polygon. All right, so already we've covered a bunch of stuff. Regular and irregular polygons. Basically, if a shape is or is not a polygon. Regular and irregular, concave and convex. Okay? Know those differences. Polygon angle sum theorem. Says that the sum of the interior angles of a convex polygon with n sides is going to be equal to n minus 2 times 180. That's the sum of the interior angles. A perfect example of this would be the sum of the, what's the sum of the angles of a triangle? It's 180, right? How many sides does it have? 3. So if you took 3 minus 2 and you multiplied it by 180, what would that equal? 180. Okay? 180 degrees. 3 minus 2 is 1. 1 times 180 is 180. So the sum of the interior angles of a polygon with 3 sides is 180. Okay? If you turn the page, some of the questions you'll see today are find the sum. Find the sum of the interior angles of a nonagon. If you flip back one page, on page 394, over there on the right-hand side, underneath the guy taking a picture of the penguin, there's a little table that gives you number of sides of polygons from 3 sides to 12 sides, and then the name of that polygon. Okay?
Will we have to memorize that?
Yeah, you'll have to know that.
Yo.
Alright, so if you're finding the sum of the interior angles of a nonagon has 9 sides. So to find the sum of the interior angles, you would take 9 minus 2, and you would multiply it by 180. And 9 minus 2 is 7 times 180. 1260 degrees. Okay?
Is it okay if we write like the little the table in our notes and then we can like read over and over and over again so we
That's
memorize
fine. You can write in your notes whatever you desire. Okay, if you had the same question, find the sum of the interior angles. This says of a nonagon. Let's say of a 23gon. Alright, so how many sides do you think a 23gon has?
23.
Yeah, real difficult. So 23 minus 2, and you would multiply that by 180. So 21 times 180, 3780, 3,780 degrees. Sum of the interior angles of a 23 gon. Now, you have to read these questions carefully this week, because the next type of question you're going to get will be something like, find the measure of each interior angle of a regular and they use nonagon again. Let's use octagon. Okay, so when you have to find the measure of each interior angle, you're going to find the sum of the angles, and then you're going to divide it by the number of angles that there would be.
Oh, that makes sense.
The number of angles is going to be the same as the number of sides. Okay? So in this case, to find the measure of each interior angle of a regular octagon, the regular octagon has 8 sides, so you take 8 minus 2, and you multiply it by 180. And then you divide that by 8, and that gives you each angle. Okay? So in the numerator, you would have 6 times 180 equals 1,080 divided by 8, and that would be equal to 135 degrees. So each angle inside of a regular octagon measures 135 degrees.
So you divide it by 8 because there's 8 sides, right?
Divided by 8 because there's 8 sides, and they asked for each angle measure. In the other problem, they asked for the sum of the interior angles. So be careful when you read the problem. If they're asking for just the sum, it's n minus 2 times 180. If they're asking for the measure of each interior, it's n minus 2 times 180 divided by n. Okay? So sum equals n minus 2 times 180, and each would equal n minus 2 times 180 divided by n. So read the questions carefully and use the correct formula. All right, the second theorem in this section is the exterior angle sum theorem. All right, the last theorem talked about interior angles. This is talking about exterior angles, and it says that the sum of the exterior angle measures one at each vertex of a convex polygon is 360. So the sum of the exterior angle measures, one at each vertex, of any polygon and all polygons, all convex polygons, is 360 degrees. The type of questions you'll get will look something like, could be given a triangle. And maybe in this triangle you're given an exterior angle here, which is, let's make it 3x. You're given an exterior angle down here. We'll make this 4x. And then a third exterior angle, and we'll call it 5x. All right, so that's one exterior angle measure at each vertex. An exterior angle is formed by a side and an extension of another side. All right, so if you're asked to, in this case, let's say that you're asked to, find each angle measure. You would use the same concept that you used basically all first semester. What should these three angles add up to?
180 or 360.
360, because these are now exterior angles. They're all going to add up to 360 degrees. So you're going to solve for x first, and then you're going to plug in the multiplier. So what's 3x plus 4x? 7x plus 5 more x. So 12x equals 360. If you divide each side by 12, then x, or your multiplier, is equal to 30. If x is equal to 30 and you have to find each angle measure, then you're going to substitute. So this angle would be 3 times 30. And of course this picture is not to scale, so this first angle would be 90 degrees, right? 5 times 30 would be 150 degrees. And 4 times 30 is 120 degrees. So those would be your three angle measures. Those would be each of the three angle measures, exterior angle measures for that polygon. Any questions? Your assignment for today is on page 398. Two through 15. (22) through 26. And then please get back in the habit of checking Edline for homework.